So now we are recording. So, the main idea that I want to bring about right now is how to understand this hypothesis testing. So we have two different hypotheses. One is the null hypothesis. The other one is the alternative hypothesis. So one of them is going to become the claim, and the other one is going to be the complement. So once we identify the alternative and the H naught and the H sub A, so we identify the claim and the complement, and then we proceed to determine whether we are going to run a left tail test, a right tail test, or a two tail test, right? So those are the things, and everything has a very particular language. So I was mentioning, for example, in order to determine one or the other. So for example, in this case, if the statement makes like it's greater than, so we are determining the alternative hypothesis as the claim. So we take the counter argument for the null hypothesis. So if the argument is greater than, so this becomes the claim that is going to be the complement. So if, for instance, the statement says at least this value, so at least means greater than or equal to, so we are identifying the null hypothesis as the claim, thus the other one becomes the complement. So it all depends on the language of the problem. So, and that's how we are going to determine whether or not this is a right tail test, a left tail test, or a two tail test. So that is very important. Remember also that the H null, H naught, is gonna be the item that we are gonna prove or disprove. So, and once we prove or disprove, so we are gonna make a determination. But also the H sub A is very important because that's what determines the type of test that we are gonna be doing, right? So all these things are kind of like a lot of things to consider for one particular case. So we had some examples. I went through some of the examples, some of the potential problems. So we have different type of errors, and we want to minimize the error. So to minimize the error, we are going to choose a level of significance. So the level of significance, we are very familiar with this, is the alpha that we were discussing last time. So the alpha is 1 minus C. So that alpha becomes the highest allowable mistake that we can make in order to make a decision on a particular statement. So, so that's very important to know. Levels of significance go from 10%, 5%, 1%. In some cases, we have the 0.001%. So that means that things are going to be at the minimum allowable mistake. I was mentioning that before. For example, this COVID vaccine, I'm very sure that they are using a 0.001% or less as the level of significance. So remember that these statements are very important. It can be deadly for many cases if we make the wrong decision. So we want to minimize the margin of error or the allowable error that we can make. So that's the reason of this level of significance. So we are going to do testing for population parameters such as the mean of the population, the proportion, and the variance of the population. So we are going to do the test statistics on the sample mean, the sample proportion, and the sample variance, and or standard deviation. So we have the tools. We did that before. So we use for the sample mean, the C-score when the samples were bigger than 30 and or sigma was known. So we use the T distribution when the sample was less than 30, and we did not have any information on the sigma, on the sample population standard deviation. So same thing for the sample proportions. We are going to use the C-score. So once again, this is kind of like a binomial experiment. We are going to do an approximation to, or we are going to use the C-score to compute the values. So we went through this, the nature of the test. We mentioned the left tail test, the peak of the sign goes to that side. Of course, that's going to be a left tail test. We have a right tail test when this is greater than, so we're going to be measuring this. And the two tail test is going to be equal, so it's going to be given by the non-equal sign. So if the level of significance is 5%, we're going to divide the value between the two different tails, right? So so that's how we do the case. So here we have the case when we have the extracurricular activity is 61%. So we are assuming that the claim is going to be the proportion is equal to 61. So the complement becomes the not equal sign. But remember, this non-equal sign is telling me that this is a two-tail test. So we have a left tail test, and we also have the case for a right tail test. So so we have some decisions that we have to follow. We have two different methods to make a decision. The first one is to compare the p-value with alpha. So we are going to find the p-value based on our data, and we have a level of significance. So at the end, we are going to compare these two. Is it in Blackboard? All the materials are in Blackboard. At the end, I'm going to repeat that. But yes, all the materials are in Blackboard. You can download them very easily. So we mentioned that before. If P is less or equal than alpha, then we're going to reject H naught. If the p-value is greater than alpha, then we're going to say fail to reject. So it's not reject and accept. We're going to reject, or we're going to fail to reject. So because we don't have enough evidence to support that statement. So this is the language that we need to use. I went through this last time in the video. So those are examples of how we need to use the language when we have a rejection of the H naught, when the H naught is the claim, or when the H sub A is the claim. So we can do all this. Well, we can use this as a basis to make a determination, right? So so once again, hypothesis testing for the mean large samples. So we are going to use the p-values to make a decision. So I'm going to tell you this is one way to make a decision. We have a second way that we are going to analyze in few more minutes. But the first approach is that I'm going to use my data. I am going to find the area under the curve. And if the area under the curve is less or equal to the level of significance, we are going to reject H naught. Otherwise, we are going to fail to reject. Okay. So let's keep an eye on this. This is a very good example. The p-value for a hypothesis test is 0.0237, right? So let's say that after computing the C-score and the value under the curve, we come up with this p-value, which is 2.37%. So if we set the level of significance at 5%, it's very clear that the p-value is less than the level of significance. So we are going to reject the null hypothesis. So remember, again, p-value less or equal than alpha, we are going to reject H naught. So, but what happens if the level of significance is only 1%? So it's very clear that the p-value is greater than alpha. So because p-value is greater than alpha, we are going to fail to reject H naught, right? So this is very simple. So we have a case when P is less than alpha, we reject the null hypothesis, and then we have the case where the p-value is greater than alpha, and we fail to reject the null hypothesis. So keep that in mind because this is very, very important. The rejection or or failing to reject the H naught is something that many people, I mean, it's kind of like needs a little bit of thinking. So so finding the p-value, so that's something that we already know how to do. After determining the hypothesis test, a standardized test statistic, so and the test statistics corresponding area, do one of the following to find the p-value. So to find the area, for the left tail test, we are going to find the area under the curve that is under the left tail test. For the right tail test, we're going to find the area that is on the right tail. So we need to identify the critical value. We need to measure the area under the curve. And because it's to the right, we have to subtract from 1. We know how to do it. And for a two-tail test, we are going to multiply the area under the curve for one of the tails. And then, so we are going to multiply by 2 the area under the tail statistic. So if the value of the p-value on the right tail is 1.5%, so we have to multiply it by 2. So the area is going to be whatever is on the tail multiplied by 2. So we are going to see how it does work. So in this case, I already made some numbers. So this is a left tail test. So basically, so find the value for the left tail hypothesis test with a test statistic of C equal to minus 232.23. Decide whether to reject H naught if the level of significance is 1%. So we find the area corresponding to the C score. So just give me 1 second. Let me get my cheat sheet. Just give me 1 second. So what we are gonna do in Excel, oh, I think I have it here. So in order to find the C score, we have the C score. This is to find the probability. So we are gonna write the norm that this, and then the C score and true. For example, in this case, we have a C score of minus 2.23. So I guess that's the one, minus 2.23. So this is the area under the curve. So probably let's make it with less zeros.
Professor.
Yes, young lady.
Can you did a little more bigger the image?
Oh, so make it
please.
bigger?
Yes, please.
Sure, sure. So so I'm gonna zoom this. I'm gonna put 200. So can you see it better now?
Yes, thank you, Professor.
Sure, sure, of course. So have a C score, find the probability. So in this case, so I have the C score of minus 2.23. So I have the C score of minus 223. So the area under the curve is going to be 0.0129, right? So in this case, if the level of significance is 1%, of course, the p-value here is greater than the level of significance. So what might be the choice? So in this case, we go back to our, so p-value greater than alpha, then fail to reject. So that's what we did here. So because the p-value is greater than alpha, we fail to reject H naught. Remember, we are gonna always reject H naught, okay? So that's something that we need to keep in mind. So I hope this is clear. We have another case. Find the p-value of a two-tail test with the statistic of C equal to 2.14. C value is 2.14. Decide whether to reject H naught if the level of significance is 5%. So what I'm gonna do here, so basically we have a two-tail test. So we have a a minus 2.14. So, and a 2, so because we are dividing the area under the curve, so so we have two tails. So the critical value of the left tail is going to be minus 214. And because it's symmetric, we're going to have a 2.14 on the right side, right? So we can either find the value to the right of this, or I can easily find the area under the curve here. So I'm going to do the following. I'm going to use the minus 214. Here I'm going to use this code with the minus 214, and that is going to be 1.6617. So this is the value, but because it's a two-tail test, I am going to multiply this value. So I'm going to put it here, maybe here, equal this value times 2, right? So why? Well, because I know this is a two-tail test, and as a two-tail test, I'm going to find the area under the curve, right? So, I think that's what I did here. So I think that's what I did here, 214. So I found the area under the curve. So remember, for a left tail test, so we have this value multiplied by 2. Okay, so I guess that was the case. So 0.0323. So this 0.0323 is less than alpha. So therefore, we are going to reject the H naught, right? Is this clear? So is this clear? So the point is, we have a C-score. We have to find the probability. The probability is the area under the curve. So that's going to be the value that we are going to consider for the p-value, right? So in this case, for example, the area to the right. So how can we do that? So I think I had an example here and I deleted it. So edit, but we will find an example for that. So we have, so once again, the left tail test, we have the two tail test, and I hope we have a right tail test. We don't have. So let me see for the right tail test. So we are gonna do, so let's say that is 214. How much is gonna be? So here is gonna be 1 minus the normal distribution. So if we want to look for the left tail test, so we are gonna write the norm, that is that distribution. So I want you to make a modification here. You are gonna do the 1 minus the normal distribution. Why am I making so many mistakes today? So here we are gonna do the 1 minus the norm dist, so the C-score and the true. So in this case, for the left tail test, remember, this is always a negative C-score. For the right tail test, this is gonna be a positive score, but we are gonna be subtracting from 1, because remember, if we have this, so let me do it here, or let me open something different, new document. So we can do the following. If we have an area under the curve, so sorry for the bad, so the CS, the CS score is 214, so we have the 2.14. So this is a positive CS score. So all I can do is to find the area to the left, but if I want to know the area to the right, I subtract 1 minus the area to the left, right? So that's what I'm gonna do. So in this case, we have the CS score to find the probability for the left tail test, for the right tail test, and for the two tail test. So I'm gonna find the area on the curve from the negative side, and then I'm gonna multiply it by 2. So that's what I did here, 2 times the area under the left tail test. So I hope this is clear. So we have this little cheat sheet that you can use to find the corresponding values. So you can erase this and just type the values here, and just add the Excel function with the corresponding C-score. Okay, so so that is one. So so once again, we have the p-values. So for the p-values, if we have the C-score, we can find this value. But remember, what happens if we don't have the C-score? So we have to find the area under the curve. We already know how to find it. So if we are given mu, x, alpha, and sigma, no, but if we are given, yeah, mu, alpha, sigma, so we are going to be able to find the values. Okay, so so let me go back. So we have the left tail test, the two tail test, and also we added the right tail test. Okay, we cover all the corners. So what happens next? So now we have the idea that we can, so we are going to have a problem. We want to prove or disprove a claim, and that claim is going to be tested with some statistical devices that will allow me to say with certain level of significance, 90, sorry, 10%, 5%, 1%, 0.1%, whether this I have the strength to disprove or prove that particular statement. So we are going to use the C-test for the mean mu. So so we are going to use a sample, and that sample is going to provide the statistical power to allow me to prove or disprove that claim. So for example, in the case that we are claiming that, as in the previous case, that the amount of salmonella in the chicken produced by a certain company exceeds the USDA requirements. So we are not going to test all the chicken. We are going to take a sample, and we are going to come up with a statement that allows me to say, well, I think this chicken exceeds the USDA limits, and I am allowed to make a mistake only 10% or 5% or 1%, right? So we are going to use the C-test for the mean mu. So it can be used. So in these cases, it can be used when the population is normal and sigma is known, or for any population when the sample size is at least 30. So remember, 30 allows me to use the law of the large numbers, and I can assume normal distribution. So we are going to use a test statistic that is, in this case, is the sample mean. So we are going to standardize those values. We are going to produce a standardized value using the C statistic, the C score. So we are going to use the C score. So we have the sample mean minus the hypothesized mu, and we are going to divide it by the standard error, right? So when the sample size is greater or equal to 30, the sample standard deviation, so instead of using this sigma, we can use the S, okay? So, but we need to know that the population where the sample is coming from is normally distributed. So if we don't have sigma, we can use S instead when this occurs, a sample greater than 30. So, so what do we have to do? Well, this is a step-by-step, and sometimes we don't like to do too much work, but I think it makes sense, because once you are identifying each of these elements, solving the problem is going to be very, very simple. So we are going to state the claim. So we are going to convert this verbal statement into a mathematical formula. So we are going to identify the null and the hypothesis. Then we are going to identify which one is the claim and which one is the complement. So we need a level of significance. So then we need to determine the standardized test. So we don't have to do many things. We already have the norm is that this to find, well, this is for the area under the curve. So that's what we were doing here in case that we need to find the area under the curve. So, and then if we have to find the p-value, we are going to use the left tail test, the right tail test, or the two tail test. So we have the tools to decide that. And then once we have these p-values, we are going to contrast the p-values with the alphas, and we are going to determine whether we reject or fail to reject H0. And then we are going to make an interpretation of the decision in the context of the original claim. So that sounds like a tongue twister, but do it in reality is not going to be that difficult. So so this is an example, and I guess after reviewing the example, we are going to see that is not that difficult. So let me erase this. I think might be good for. Oh. So let me erase this part, of course. So I am going to determine two things. So first of all, if I am starting a case like this, I'm going to sketch my two hypotheses. So we have the H0, we have the H sub A. So the first thing that I have to make sure I know is whether I am assessing mu, the population proportion, or sigma square, which is the variance of the population. So I need to know from my case whether this is going to be any of these parameters. So in this case, in an auto racing, a pit crew claims that the mean pit stop time for 4 new tires and fuel is less than 13 minutes. So first of all, the parameter I want to analyze is going to be mu. So I'm going to type mu into, and then I recognize that the amount is 13 minutes. So I'm going to say 13 and then 13. And then I'm going to see what is next. Well, it says less than. So remember, less than is this sign. So this is going to be the claim. And the complement is going to have the counter argument. So if this is less than, it has to be greater than or equal to 13. So so I already built my hypothesis. So now I'm going to build the data that is going to be very helpful for me to produce these results. So so I have that the mu is 13 minutes. So the sample size is 32. So do I need to use sigma? Well, if I have sigma, I will be happy. But if I don't have sigma, probably I can use the sample standard deviation. So I need to know that those values are available. And because the sample is greater than 30, I can assume normal distribution, either with or without sigma. So it says a random selection of 32 pit stops times has a mean of 12.9 seconds. So this is the observed mean. This is the hypothesized mean. So we have two different values of the mean. This is going to be the hypothesized mean. This is the mean that we are going to observe from our experiment. So, and the standard deviation is 19 seconds. So I have a standard deviation of 19 seconds. And once again, the sample size is 32. So with that information, so I am gonna build this case. So my level of significance is gonna be 1%. Well, that makes sense. The times are too tight. So the seconds are, this is seconds. So for me, a 10%, a 5%, even a 1, probably a 1% is gonna make sense. But I want to be incorrect the lowest amount of times. So I'm gonna use a very low level of significance. So in this case, I'm gonna find the C-score. So the C-score, remember, in a sample, we're gonna have the the sample mean minus the population mean. Once again, the observed minus the hypothesized mean divided by the degree of variability. So in this case, because it's a sample, we have to account for the sample size. So we solve this, we find the area under the curve, which is the C-score, and then we go to the table and find the area under the curve. So once again, this is a left tail test. So in this case, my p-value is 0.0014, and the level of significance is 1%. Of course, this is very low compared to this. So we are going to reject H naught. So when we are rejecting H naught, we are now accepting the claim as a true. So if you say, well, this is not true, then that becomes a true. So at the 1% level of significance, we have sufficient evidence to support that the claim that the mean pit stop is less than 13 seconds. So so that's very important. So we were able to compare the p-value, which is the area under the curve, based on our data. So, and I compare the area under the curve with the alpha, and I determine that the p-value is less than the level of significance. So I determined to reject H naught, and I wrote the statement. So how can we do this in Excel? So that's very, very simple. Let me make this little small. So in this case, so we have, for example, I built here a formula. So this is the square root of B10. So B10 is my the square root of sigma. Sorry, the square root of the sample size. So all I have to do is the following. I am gonna include the X bar. So let me go to the previous one. So I'm gonna include the X bar. In this case, the hypothesized, the observed mu is 12.9. The hypothesized mu is gonna be equal to 13. Sigma, which is the standard deviation, is 0.19. And the sample size is gonna be 32 cars, right? So that is my, this is my alpha. So my alpha is gonna be 1%, right? 0.01, right? So I already wrote these equations here. So if you can see, the C is basically equal to the X bar minus the mu divided by the sigma divided by at the end, at the same time, by the square root of my sample size. So my C-score is minus 2.997. So if I compute this, so here I have the norm that is that this. So I am taking the area under the curve of this C-score. So so let me do a little graph here. So what we have here is the following. So this is the data that I have. I computed the square root, so that is helpful for me to use this formula. You can write this formula very easy. So it is, I mean, at this point, you should be able to write this formula. So is the C-score formula like this? So that's exactly what I did here. So this is the C-score. This is the, so once again, the observed mean, the hypothesized mean divided by the by sigma, which is divided by the square root, in this case, of the sample size, right? So my C-score, so once again, let me do this here, draw. It's got kind of very tight, but I will try to make it here. So we have, so mean is gonna be well, hold on. So in this case, let me make it more simple. We don't have to do this. So what I'm gonna do is my CS score is gonna be, so we are gonna call this point the critical value. The critical value, right? So this critical value is gonna help me to identify the area to the left or to the right. So in this case, the CS score is gonna be minus 2.98, right? And the area under the curve is gonna be 0.0001, let's say 5, right? So if I compare this value with this alpha, of course, alpha is greater than the p-value, or the p-value is less than alpha. So remember, that is the way we can rule in favor of rejecting H naught. So here, what I'm gonna say is the following: because the p-value is less than alpha, then we reject H naught. Remember, H naught is the one that we are targeting. So the H naught, in this case, I wrote the question here. So this is the complement that's gonna be the claim. So because we are rejecting the H naught, we have enough evidence at the 1% level of significance to conclude that the mean pit stop time is less than 13 minutes, okay? I hope it's clear. So if you follow, so you don't have to follow this, but and you can build it very easily without any problem. So here, as you can see, I build the same formulas. In this case, I'm doing a two-tailed test. So we are gonna see a case for a two-tailed test. So so far, this is a one-tailed test, a left-tailed test. So we have a second case here. So let me erase all this nonsense. So we have a second case that we can use to do the hypothesis testing. So so here it says the National Institute of Diabetes and Digestive Kidney Disease reports that the average cost, so once again, H sub 0 with H sub A. So we have the two hypotheses. So I am noticing that they want the average cost. So is the mean cost of this bariatric surgery, which is a weight loss surgery, is 22,500. So my value is gonna be 22,500, 22,500 in the two cases. So, and here is the word is. So this is the most important thing. So that is suggesting that is equal or not equal. So that is gonna be the claim. And that is gonna be the complement. So also, because this is a non-equal, so we have a two-tailed test, right? So so we have the values. So once again, mu is equal to 22,500. N, sample size, is equal to 30. So find the average cost of this. We do a test. We do a sample of 30, and that sample mean tells me that the cost is 21,545, and the standard deviation sigma is equal to 3015. So at this point, I don't care if this is the sample mean, the standard deviation of the sample of the standard deviation of the population. as long as the sample is at least 30 elements, right? So I'm gonna do here this computation. So let me pull this a little bit to the left, okay? So what I'm gonna do here, so here, this is gonna be a two-tailed test, right? So what does it tell me? Well, it tells me that, for example, here, the X bar is gonna be 21,545. The hypothesized mu is gonna be 22,500, according to this, right? Sigma is gonna be 3,015 in a sample of 30 elements. So notice that as soon as I type 30, so we are going to have the C-score. Why? Well, I already typed the formula to ask this cell to find the C-score, and this is to find the p-value that corresponds to this score. So we are going to use, so this is the C equals to the X bar minus the mu divided by sigma divided by the square root of my sample size. So in this case, the trick is the following. We have a two-tailed test. So what we are gonna do here is I am gonna use a 0. So this is an alpha 5%. No, that's fine. This is alpha 5% that we need here. So in this case, let me, what did I do? Yeah. So, so in this case, I have the, so how did I find this? So the square, this is the p-value. So whatever the p-value I found here, so it's gonna be multiplied by 2. So in this case, so let me see yeah, so this is the value. So the p-value is 8%. So I have to, no, sorry. The p-value of this is 4. So if I find this value without the 2, it's gonna be 4%. But if I multiply this by 2, as I am supposed to do it, so I'm gonna find that the area under the curve. So in this case, the only change is that I am multiplying the C-score by 2, right? So, so I am going to find the C-score, I'm gonna find the p-value, I'm gonna multiply it by 2. So in this case, the p-value is greater than, so the p-value, sorry, is greater than the alpha. So in this case, because that is the case, because the p-value is greater than alpha, then we fail to reject H0, right? So in this case, the claim is here, I think is 2250. And this is 2250. So make the change. So this is the value 2250. So the claim is the null hypothesis. Sorry, the claim is the alternative hypothesis. So because we are failing to reject, we don't have enough evidence to support the claim. So, so in this case, we are not disqualifying this. So I cannot say that this is true. So because I'm not sure, I just know that I don't have enough evidence. So at the 5% level of significance, there is not enough evidence that the mean cost of the bariatric surgery is different from 2150. It can be 2150, it cannot be, I don't know. Because with the evidence that I have, I am unable to disqualify this statement, right? So in this case, I'm gonna fail to reject H0, and I am gonna say that there is not enough evidence that the mean cost of this surgery is different from 2150. Okay, so so that is the case. So in this case, once again, the trick is that the C-score is gonna be multiplied by 2, because this is a two-tailed test, and I am gonna confront this C-score, this p-value with the C-score, and I'm gonna make a recommendation. In this case, is to fail to reject H0. Okay, so that is one of the cases. So we can do one area, so one avenue here is to use the rule number 1, where p-value is less or equal to alpha, right? Or the p-value is greater than alpha. So in this case, reject H0. In this case, fail to reject H0. Okay, so we have this type of considerations. Either we reject H0 because we are comparing p-values with alpha. So so that is one of the rules. Let me put this in a let's say home. I'm gonna give it a different color, very light, a green color. So I'm gonna have this rule very clear to me, because whenever I am using this method, I am gonna compare my alpha with my p-value. But there is another way to do it, and many people do it. They use what is called the rejection regions, right? So these rejection regions are also very important. So in many cases, you can say, well, alpha versus p-value, okay, so we can reject or fail to reject. So in the second case, rather than comparing the area under the curve, so remember this p-value represents the area under the curve, and the alpha represents the level of significance. So we can use the C-score and the C-score of this, right? So if I am using the C-score that I obtained from here, so in this case, I am gonna use this C-score, and I am gonna find the C-score for this, and then if, so listen to this. So the rejection region or the critical region, the range of values for which the null hypothesis is not probable. If a test statistics falls in the rejection region, so the null hypothesis is rejected. So if the critical value C, well, in this case, the critical value C, so this C that we have here, this C that we have here, separate the rejection region from the non-rejection region. So let's take a look at this. So rather than using the p-value and the alpha, I'm gonna use the C-score of my data. So I'm not gonna find the area under the curve. I'm gonna find the C-score, and I'm gonna compare it with the C-score that arises from alpha, right? So if this is a 5%, a 2%, a 10%, so I'm gonna find the C-score that corresponds to the level of significance alpha, right? So I'm gonna compare the C-score with the C-score. So this comes from my data. So the data that I have in my case, and that comes from the level of significance. So, and the rule says if these C-scores, the C-score that comes from the data falls inside the rejection region, we are gonna reject H0. If the C-score from the data falls outside of the rejection region, we are gonna fail to reject, okay? So that's what we are looking at here. So let's see a case. So finding the critical values in a normal distribution, first specify the level of significance, decide is whether a left, right, or two-tailed test. So same thing that we're doing. So if left tailed, find the C-score that corresponds to an area of alpha. If right tailed, find the C-score that corresponds to the area 1 minus alpha. And if this is a two-tail test, find the C-score that corresponds to half alpha and 1 minus half alpha. So sketch the normal standard distribution and draw the vertical line at each critical value and shade the rejection regions. Sounds like a multi-step thing, but actually is very, very simple. So let me do this here. So we have, it says find the critical value and the rejection region for a two-tail test with an alpha that is equal to 0.05. So if this is a two-tail test and the alpha is 0.05, so we have the 5% divided by two different areas. So this area is going to be 25% or 2.5%, and this is going to be 2.5%. So remember, the cumulative area in this, let me put a little arrow here, is going to be, so what you are going to be looking for in your table is the 0.025, and this critical value is going to be the 0.975, right? So you find these values in your table, and you are going to find these C-scores. For example, let's go here. If I find a left tail test, for example, I have the, oh no, that's the other one. So here we have the probability, and then we find the C-score, right? So in this case, the probability is 0.025. So I'm going to find the area that is the 0.025. So my C-score is 196, right? So I want to find the C-score, the area under the curve of this one. So it's going to be 0.975. So I think that doesn't work that way. So let me pretend that I didn't say anything. Oh, it's here. I don't know how I did here. Edit on the typing. So this is the area. So this is the area for 0.025. So that is going to be the minus 196. So of course, this is symmetric. I'm going to find the 1965, right? So in this case, I guess, right, so the 5% in this case is 1 minus 0.5. Let me see. I think I made the mistake last time. No, that's not. So forget this one. So if we have a left tail test, so we use the point. So we have the probability here. So I am gonna find the C-score, right? So in this case, my area under the curve to the left-hand side is gonna be 0.025. So this is my C-score. If I had an area under the curve that falls on the other side, so let's say that the C-score is not 196, but is not minus 196, but is 196. So I'm gonna use the same. So let me see. So in this case, I have the probability. So I am gonna use the, so let me figure this out. So I'm gonna put this on hold for the time being. So because this is for the left-hand side, this is for a two-tail test, right? So so this is for a two-tail test. I was measuring the area under the curve. So if my C-score here, if my area under the curve, going back. So this is a two-tail test. I am using this. So that's how I'm getting confused. So because the p-value is 5%, I am gonna use half of the p-value, right? So it's gonna be 0.025. So I have this C-score that represents the left tail. To find the right tail, I just change the value, the sign. So I have a two-tail test. If I have a left tail test, I'm gonna use for this 5%. So in this case, I'm gonna use the 0.5. That's what I had before, right? So it's gonna be 164. So if this was a one-tail test at the level of significance 0.5, so the C-score would be 164, but this is a two-tail test with a level of significance of 5%. I hope it's clear, and I hope it's not any problem. So what I'm gonna do is that I am gonna compare this C-score from the critical value with the C-score that I find with my data. So if my data falls within any of the tails, I am gonna reject H0. If my C-score that I find from the data falls outside of the rejection region, I am gonna fail to reject. Let me be more clear. To use a rejection region to conduct a hypothesis test, calculate the standardized test statistic, the C-score. If the standardized test statistic is in the rejection region, then we reject H0. If it's not in the rejection region, then we fail to reject. Any value that I find from the data falls within any of these tails, we reject H0. Any value that falls outside of any rejection region, we fail to reject, okay? Same thing, we're gonna state the hypothesis, identify the significance, blah, 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 blah. So in this case, we need to find the C-score, make sure that our sample is greater than 30, or at least we have sigma. So we are gonna find whether C is in the rejection region, we reject, otherwise we fail to reject, and then we make an interpretation in the context of the original claim. So is that simple? I guess that's very simple. So we have the following case here. So this is the rejection regions, okay? So let me pull this a little bit to the left, pull this a little bit to the right. So let me erase these numbers. So yeah, that's a formula. Let me make this yellow. Let me put a frame here. So this is a formula. So we are gonna use the same intuition. Now we are gonna find, let me make this bigger, zoom. Oh, it's already big. So let me, so in this case, I am gonna use the same procedure. I am gonna find the C-test for the C statistic for the data I have, and then I am gonna find the alpha, the C-score for the alpha. So I put this here, so this is the alpha critical value. So that is gonna be the case of my, so I'm gonna compare this alpha, sorry, I'm gonna compare this C-score. Let me, I'm gonna compare this C-score with the C-test that I am gonna perform. So I am gonna convert this alpha into a C-score, and then this C-score is gonna be compared with this C-score, and then I am gonna make a determination. So let me show you how it works. It's not that, I think I'm making things too much. So here, employees at the construction, so I have my two hypotheses, right? H0 and H sub A. So the employees at the construction and mining company claim that the mean salary, so that once again, we are doing the mean salary, which is the mu, is less than one of the competitors, which is 68,000. 68,000. 68,000. And the keyword is less than. So is less than So the counter argument is greater or equal to, so that becomes the claim, right? So employees at the construction and mining company claim that the mean salary of the company's mechanical engineers is less than of its competitors, which is 68,000. So they choose a sample. So the sample is 30 people. So so we know that mu is equal to 68,000. Let me put a K, 68,000. And the mean salary of the sample, so X bar, is going to be equal to 66,900. And the standard deviation, sigma, is 5,500, right? So I'm almost about to finish. So we have this random sample, we have a mu, we have a sigma, and we have a sample mean. So here the sample mean is 69,900. The hypothesized mu is 68,000, sorry, 66,900, 68,000. So sigma is going to be 5,500, and the sample is equal to 30, right? So once I type this, I am going to find the C-test. So we have this C-test. We have very clearly a left tail test. So we have to account for that. So so we have a level of significance that is 5%. So if I didn't have this, now I know that this is a 5% alpha. So I'm going to say a 5% alpha. So what did I do here? What did I do here? It's 31. Oh, 0.05%. So what we have here is the following. So we compute the C-score. So we have a C-score that is minus 1.10. So this is my normal distribution, the standardized. So this is the critical value. So the critical value is the one that comes from the alpha. So we have the following. So let me do it here. Let me erase these arrows for the time being. So what we have is the following. We have a standardized distribution, normal distribution. So we have a C-score. This C-score comes from alpha. So this is the critical value. So we have a minus 164.5, let's say, right? Or 64. Let's leave it like this. 1.64. So that is my C-score. This number is minus 1.095. So it's almost 110. So is 110 to the left or to the right? So remember, this C critical is what separates the rejection region from the non-rejection region. And if this number falls within the rejection region, we are going to reject. If this number falls outside of the rejection region, we are going to fail to reject. So in this case, this is my C score coming from alpha. This is my critical value. And my test statistics is 1.1. So 1.1 means 1.1 standard deviations to the left. So my C score is going to be here, minus 1.1, right? So that means that this value falls outside of the rejection region. Thus, we have to reject, we have to fail to reject. So I'm going to say the following: because the C test is outside of the rejection region, we fail to reject H naught, right? So, and then we can say that at the 5% level of significance, there is not sufficient evidence to support the claim that the employee's mean salary is less than 68. So once again, here my claim is the alternative. So I am failing to reject this, so I don't have enough evidence to support the claim. So that's what I'm gonna say here, that at the 5% level of significance, there is not enough evidence to support the employee's claim that the mean salary is less than 68,000, okay? So is there any question so far? Is there any question so far? So if not, we have a second case. Let me go very quickly. So we are approaching to the end of the class. So we have here another case for this, right? So so here, this is a two-tailed test. As we can see, we are going to use the is. So in this case, this is a little trick here, because here I have to use half of the alpha, because I am going to use a two-tailed test. So the US Department of Agriculture claims that the mean cost of raising a child from birth to age 2 by husband-wife families is 13,120. So I have my H naught, my H sub A. So once again, the parameter I want to estimate is the mean cost. So the mean is going to be here. The mean is going to be here. So is 13,120. 13,120, right? So is means is equal. The counter argument is not equal. So very clearly, this is a two-tailed test at the 10% level of significance, right? So we have the mu, we have a random sample of 500 children, we have a mean cost for the sample and a standard deviation, right? And the level of significance is gonna be 10%. So here, I think I have the wrong arguments. Let me erase this. So, so that should be a formula. So this is a formula, as we can see, the square root of the sample size. So I'm gonna use the X bar, which is 12,900 is 12,925. The hypothesized mu is 13,120. Sigma is set at 1745. And the sample size, we have a huge sample size. So we don't have any doubt that this is going to be normally distributed, right? So we have 500. So here we have the square root of the sample size. Here we have the C-score. So let me use yellow here. In the two cases, use yellow. I say yellow and make little frames. So in this case, I found the C-score. So this C-test corresponds to this data. So this data is what gives me the C-test. And this C is coming from alpha, right? So the trick here is that I don't want the whole alpha. I want half of the alpha. So if the level of significance is 10%, to find the C-score, so the critical value, is going to be only half of the alpha. So what I'm going to do here is that I am going to use the same Excel function norm, that is that IMV, to compute the 5%, not the 10%, because this is a two-tailed test, right? So I'm going to use half alpha. So in this case, I have the critical value and I have the C-test that comes from my information here. So what I have here is the following. So I have the standardized normal. So I have a two-tailed test. So one side here is minus 1.645. and this side is 1.64, right? So remember, this is a two-tailed test. So this is the rejection region on the two sides. If my test statistics falls within these rejection regions, we reject H naught. If we don't, if it falls outside, we fail to reject. So in this case, we have a C critical coming from the two-tailed test from alpha 10% that is equal to 164. And we have a test statistic that is 2.5 standard deviations to the left. So this is 164 standard deviation to the left. So the 2.5 very clearly is somewhere in here. So we have a 2.5, of course, a minus, standard deviations to the right. So my standardized test statistic falls within the rejection region. So then I reject H naught. So in this case, so let me take a look at this. So we were looking at this, and that happens to be the claim. So let me do the following. So this is going to be the claim. So that means that if we are rejecting the H naught, so we have enough evidence to support that mu is not equal to that value. So in this case, I think is 1320, and this is 1320. Okay, so so that's very simple. We have two different methods. One is to use p-value versus alpha. The other one is to use the 2C scores and determine whether the standardized test statistics falls within the rejection region or not, and we make the call. Okay, is this clear so far? Do you guys have any question? Yes, no, maybe? Let me stop the recording